Okay, so now we want to look at the second case study problem we had. I'm going to ask that you go ahead and pause the video and try to answer the first two questions. Okay, so I'm going to assume that you've paused and you've read it, and I'm going to continue on now. So our two hypotheses, okay, so we look at this and we realize that this is a manufacturer's claim. Okay, Bardo's advertising loaves of bread and he's making a claim about the average weight. And so we know that whenever we have a manufacturer's claim, the null is always the manufacturer's claim, and the alternative is always the claim against the manufacturer. So the null is the manufacturer's claim. And here this is that mu, the average loaves of bread, are equal to the average weight of the loaves of bread is 16 ounces. The alternative in this sort of scenario is always against the manufacturer's claim. And by the way, you can see this if you read the problem statement kind of carefully. It says that the customers seem like they're being shortchanged. So what would they be claiming about the population? They'd be claiming that the loaves in the population were smaller, and that would be manifested by a lower weight than what was advertised. Okay, so those are our two hypotheses. And actually here it says run a hypothesis test at alpha equal 10% to determine if Bardo's customers are right, and what they're claiming is that they're shortchanged. That's what we're testing. Okay. What is our sample size and our sample estimate? A good idea in these problems is to always locate the numbers and try to identify what they mean. So I have a random sample of 45 loaves, so I know that here n is equal to 45. Okay. And the average weight comes from the sample. So this is a sample average. Right? So mu hat is equal to 15.7. All right. So now we're ready to start doing some calculations. So what is a null distribution? Well, first of all, we have to check that the conditions of the central limit theorem are satisfied. First, do we have a random sample? And the answer is yes. We're given that he takes a random sample, right? This is given in the problem statement. Is the sample large enough? Notice that here we don't even really have to consider sample size here, because remember that when we're dealing with the central limit theorem and quantitative variables are involved, we only have to have a normal distribution. The sample size is actually not important if the distribution is normal, and it is. We're talking about deviations from a manufacturer's claim. So here the answer is yes, but there's two possible reasons. First of all, n is greater than 30, but also our variable has a normal distribution. Okay. Is our sample too large? Well, probably not. To be too large, the total population would have to be 450, and we assume that he probably makes more than 450 loaves of bread, so it's probably not. Okay, so now we're ready. So what is our null distribution? Well, given that the assumptions for the central limit theorem are satisfied, we know that sample means that come from a population where the mean is 16, the population average is 16, and the standard deviation is 1 divided by the square root of 45. That's the standard deviation of mu hat. this is what sample means look like. Okay? So let's go ahead and plug this into Excel now and see what we get. So we're going to have to create a new sheet for quantitative variables. So this is hypothesis tests for quant variables. In other words, we're doing a hypothesis test on mu. And as before, let's go ahead, we'll blow this up a little bit. Let's think about all the things that we need. Well, we're going to think about the type of test, right? We know that there's going to be a lower tail, a two-tailed, and an upper tail. Okay? And then the input, if we think about the input here, okay, we're going to need sample size. We're going to need mu hat, our sample mean. We're going to need mu sum 0. In other words, the mean under the null hypothesis. And we're going to need sigma. This is going to be the standard deviation of the variable. And in this case, as we mentioned before, this is going to be estimated. We're going to have to use the sample standard deviation. Okay? So this is going to be our input right here. And here we'll put this in a certain color. So if we think about what's going on in the problem that we're looking at, we're doing a lower tail test, right? We're seeing if the mean is less than 16. So we're clearly doing a lower tail test. So we're in this row. Our sample size is 45. Our observed sample mean was 15.7. The mean under the null hypothesis is 16. And the standard deviation of our variable is 1. Now we need sigma of mu hat. So remember what this is. This is equal to sigma sub x, divided by the square root of n. This is the standard deviation of our estimators. Okay. And this we get from the central limit theorem. So there's the standard deviation of the variable divided by the square root of, the sample size. And there we are. So what we know now is we know that if the population mean really is 16, sample estimates that come from this population have a normal distribution, the mean is 16, and this is the standard deviation. And I'm going to format these a little nicer. Okay. Now we want the p-value. So the p-value, remember what it is, it's the area in the tails. It's the area in the tail of our estimator. And you have to remember, when you have a two-tailed, you have to multiply that by 2, right? But in this case, we don't. So it's going to be 100 times norm.dist. And there's my observed value. This is the mean of the normal distribution. This is the standard deviation. And so roughly we have 2%. Our p-value is roughly around 2%. Okay. Let's go back and answer our question. So our question asked us at an alpha of 10%. What do we decide? Okay, so our alpha was 10%. So we're going to use the fact that our p-value, which was around 2%, is less than 10%, which is equal to alpha. So we're going to reject the null. P-value less than alpha, reject the null. Sometimes people have a little rhyme. When the p-value is too low, the null must go. Okay, so what is our conclusion? Well, we would say at a significance level, of 10%, we find there is sufficient evidence to conclude that the average weight of Bardo's loaves is less than 16 ounces. Notice that this is the alternative. Okay. So we find there either is or sufficient evidence to support the alternative. And in this case, we find there is. All right, good.